I was thinking about these damper mounts last night. I was actually thinking about it when I was making the film yesterday, about how the way I've done my model means these are handed. And I think even then it was occurring to me at the time that's a bit daft, making a part that can go either side of the car handed when it doesn't need to be. And the mistake I made was having it so it's oriented with the single hole at the top of the angle, if that makes sense. So that means when it's on the car like that, the hole pattern means it's effectively handed. All I need to do to fix that is rotate the holes effectively. So if you make it so that you've got two holes at the front and one at the rear, then you can flip it over and it'll be the same both sides of the car. So instead of being, it's a bit hard to see, instead of it being, I have to think which way around this goes, like that, you can flip it and the holes don't matter, they're the same on both sides. Which means instead of drilling this on the mill, which would mean getting a decent high-speed steel or some decent 19 3/4 inch, 19 millimeter or 3/4 inch drill bit, which is expensive for a good one, I thought, well, I should be able to set it up on the lathe and just drill and bore it out, and then I can make it the exact fit. And I was just trying to figure out the best way to mount it. And I was thinking about maybe making like a spigot thing that it bolts to with the correct angles and that kind of thing. And then I realized I can probably just do it in the four-jaw, because this is quite small. I can clamp it firmly on three sides, and it just so happens that the curvature on the four-jaw chuck fairly well matches the curvature of this piece. So it gets a nice tight grip on it. And I've got my little angle gauge there. And what I should be able to do is set this up. I can set it up so it's central between the two, effectively the side jaws and the top jaw, to get it lined up. And then, whoops, a bit wobbly. If I pack spacers under here, I've just got some washers in there now, I can actually wind this up. Because it's moving it closer in, it's lifting this side up. And you can see I can actually adjust the angle fairly well. So I can get it to that 8 degrees that I need. And then I can lock up the other jaws, and that should be good enough to hold it in the lathe, which will be much better. And then I can just use a simple boring bar to bore it out. I just have to make sure that I have the holes in the right place. So what I'm going to do is have it so that the pin, grab one of the pins, is, I think I need it the other way around. I probably want the pin, don't know that it matters. I'll go back to my original photos and have another look just to make sure. The problem is, because this is all on an angle, and the angle's quite subtle, when you take photographs of this, it's hard to see which way's up. So you can see if I rotate that, it's hard to actually know what the angle is until you put it flat down on something. Even then it's hard to see. So I just need to make sure I've got either two holes at the top and one at the bottom, or one at the top and two at the bottom. So if I bore it that way, it's going to go in like that. I think this is correct. So bore in that way. The only thing I'm thinking of is, actually I think it needs to go that way so that you can get all the bolts in. If the pin is like that, then obviously the pin would get in the way of dropping the bolt through. So I actually need to turn this around to have a single hole at the top so that the pin would go like that, because these two holes are offset. you should still be able to get the bolt through even if the pin is at an angle. At least that's what I'm thinking. So I'll just make sure that's all correct. I have this all set up in the 4-jaw. I made sure I got the angle correct in 2 different ways. One with my little angle gauge like this, measuring that angle. And I also use this protractor flat across the bed of the lathe, and I was able to measure the angle using that as well, from 2 directions, of course. So pretty certain that's close. It only has to be close enough because there's a little bit of play in there, I guess, because it's got those rubber bushes. You don't want much, obviously, but you know, a fraction of a degree, which is about how accurately I can measure it anyway, seems okay. Drilling it out is a little bit interesting because it's on a sort of flat face like that, or non-flat face, an angled face. It's hard to drill a straight hole, and on a little lathe like this where you've got so much flex in everything, this hole won't be concentric. If I start the lathe, you'll see what I mean. You can see it wobbling around there, but that's going to be okay because what I'm going to do is bore it out, and that'll make sure it's truly concentric. But even then, again, it doesn't really matter. This isn't a precision part like that. It doesn't have to run true or anything like that. It's just a pin bolted to the side of the chassis rail. So you know, in terms of the hole, close enough is going to be good enough. Because also one thing you have to consider when you're drilling through a block like this on an angle, the center point on the face isn't the center point of the axis of the part, if that makes sense. So if you imagine a block's got thickness, the center point is in the middle of the block. If you angle the block, if you had a line going through that center, your line now goes off axis a bit, and that makes it all a little bit weird as well. But at the angles I'm talking about, it's small enough that it shouldn't matter. But this is working well so far. I've got my little boring bar on there. I'll now start boring it out, and what I want to do is make the pins a nice press fit in there, so I can press them in and adjust them to get the exact right spacing, and then I'll weld them up on the back. Okay, like any job on a little lathe like this, you just have to take it slowly and gently, and do a little bit at a time, especially when I'm using little tools like this that are quite flexible. And you can feel that in the cutting, where you take a cut and then you come back and you can take the same cut again, and it'll actually cut again because of the flex in the tools. The first time it's done the cut, the tool's bent away, and then the next time it bends a little bit less. So to get a really clean pass, I have to go in 3 times. And the other thing I was worried about was pulling this off the chuck. So I was only cutting going forward, so I was pushing it into the chuck. I didn't want to risk having it pull loose. I don't think there's any danger of that, but it's just so off-putting seeing something like this in the chuck. And when it's spinning, it looks like it's not firmly attached at all, because you're so used to things running true. So having that offset on it just makes it look scary, really. So I just snuck up on it slowly, and now have it to the point where that's a good fit in there. So you can see now how I've got the angle through there, and I've actually done it the wrong way round, but it won't matter because you can see there the no, that's the correct way round. So when the bolts go through here and here, they're not going to hit the pin. So you can see how that's pretty true in there. So I should be safe to take this out and do the second one and hope I don't mess that one up. The second pin or second base plate went okay without any problems. You always still have to be really careful and sort of not get cocky on the second one and think you know what you're doing, because then it will go wrong if you stop being careful. And the other thing I always find with parts like this, and doing this saved me this time as well, because these are all hand machined by me and I'm just an amateur, there was a couple of thou difference between these pin diameters. So when I was machining or boring out the hole in the base plate, I always do the smallest one first, because then if I overshoot, there's a chance that the next size up pin will be the correct size. And in that case it was. So I started with the smallest one and I went slightly over. We're talking thousandths of an inch, but it was enough to make the pin a little bit wobblier than I liked. So I tried the other pin and that was a nice sliding fit. So when I did the second one, I had to do it to the smaller diameter and I was just really careful. I snuck up on it sort of a thousandth at a time. But now that those are both done, you can see how with the holes oriented this way around, they're not handed, and they'll fit, either one can fit on either side of the car. So with those done, I think what I need to do is probably wait until I have the bolts so I can properly bolt one side off the shock up, and then I can put the pins through that lower arm down there, and then move it and figure out how long this piece needs to be so I can cut it off to the right length, and then weld that into those base plates. And looking at it, I did a sort of test fit trying to figure out where it would go. Might be a bit hard to see, but you can see that bottom plate, the one that clamps the axle to the spring. It's kind of curved on the edges. It's not just a straight rectangular plate. It's got these scallops cut out of it. And I'm wondering now if that's to allow space for that bolt on that lower shock arm. So you can sort of see maybe in there. If the shock arm was mounted here, as the axle goes up and down, that spring mount would hit the nut. So I think with this just offset slightly so it's vertical, you can see there's clearance in there now. I'm wondering if that's why that's there. I'm not sure if that's the case, but it looks good, and it looks like that's going to work out quite nicely. So I'm really pleased with those and how those have come out. Like I say, I'm not a machinist, but just being able to do basic stuff like this on a little simple lathe means I can do these things and I can keep moving forward with this car. Otherwise I'd have to get some engineer to do that for me, and that gets really tricky because either they'd have to see the car or I have to measure everything really accurately and know exactly where it needs to go, so I can do the drawings. Doing it this way, I get to experiment and I get to mess things up and do them again and make them right. I'll clean up the lathe and I'll put the 3-jaw chuck back on, and this is getting a bit rusty, so I'll oil this up as well. One thing I really need to do is swap out my lamp here, which has got an incandescent bulb. That's a 100-watt bulb, and it's good because it puts out a lot of light, but it's actually quite hot, and apparently it's 32 degrees in here at the moment, so it's fairly warm, and having a light bulb right on top of you doesn't help either. Also with these finished, you can see what I was talking about, how when this is offset in the lathe, the axis of the hole changes. So I drilled it through from the front so it was central because that's what looks correct. But if you look on the back, you'll see the hole becomes off-center because you had it on an angle and you weren't drilling through the center of the piece, you were drilling through the center of a face. And so you can see that the pin is more offset to the side now. And this is also why you need the 2 holes at the front, because with 2 holes at the front, you can drop the bolts through. If you had the single hole at the front, you can see it does just fit. This fit has now got a little bit, oh, I think I've got the pins the wrong way around, but you could see it would get hard to get the bolt in because this ends up in the way. So that's why it needs to go that way. Just finishing up the day. I'm in my little lab again. I've been playing a little bit more with the Rotax front panel. I did a test of one of the starter buttons, and this is printed in ABS rather than PLA, and it just polishes up so much better than the PLA does. It's a much nicer plastic to work with. This was just a test one. I'm going to keep working on those, same as with the little fuse holder piece. And I am going to retry printing the whole faceplate in ABS, solid ABS, and see if that polishes up any better than this does. So that's coming along, and I've also been playing with the little model, chassis model. So again, this is ABS, and it's much nicer to work with. It glues much better, it sands much better. All the modelling products like the putty and stuff sticks to it properly. The modelling cements work on it. But I can only do so much with my printer. The resolution of the printer ends up being a problem. So for example, these are the springs printed at, effectively this is 1/12 scale. And you start losing detail in them, but for a rough little model that should be okay. I've also been playing with the laser cutter, trying to cut this thin styrene plastic for various little bits and pieces. So these little pieces here were supposed to be kind of like the front spring shackles, but my little toy desktop laser cutter there just can't really do it. Doesn't have enough power. It's difficult to cut because it's white, which is why I was playing around with blackening it out. Sometimes that helps. Putting masking tape on top of things sometimes helps, but in this case it hasn't really helped that much, and it just isn't cutting it all well. So I'll probably have to make little pieces like that by hand, but that's okay. It's not a hugely accurate scale model. It's just a little toy, a little distraction, but the chassis definitely come out okay. Obviously it'll look a lot better when it's been a bit more sanded and it's got some primer on it, but that's basically what I started with when I started building the Riley, a bare chassis and a pile of parts.